In economics, it is a common practice to have a function that depends on many variables. This function receives the name of multivariate function. This is useful when working in data analysis. For example, when designing regression models with the intention of exploring which factors affect our dependent variable. To cite few cases, how income and age affect traveling spending, how fertilization and irrigation influence corn production. We have seen partially the properties for multivariate functions when we defined functions and their algebraic operations. However, in this unit, we will learn how the property of ceteris paribus is applied in order to evaluate economic behavior in production and consumption. In this unit, we will learn about partial derivatives and their principles. Specifically, we will learn how to take a derivative with respect to one variable while holding the other variables constant. Quotient, exponential, product, and the power rule, which are methods used for derivation, will also be applied here. We will also use second partial derivatives to identify the maximum and minimum points of a function. We will use a property that holds for cross partial derivatives to check if our answer is correct. On the other hand, we will optimize functions when there are two independent variables in the function. In particular, we will make use of the first partial derivative to find our critical values, and then the second and cross partial derivatives to classify our points in relative maximum, minimum, or saddle point. This is key to understand how to optimize profit and other functions with multiple outputs, which is a more realistic representation of what happens in the economy. We will learn about constraint optimization and how to use Lagrange functions to optimize them. Finally, we will understand how to apply the Kramer rule in conjunction with Lagrange functions in the special case where the first order partial derivatives for all variables are linear.